Recording. Okay. So today is lecture lecture number 13. Lucky number 13. And it's the 24th. Okay. So what I want to talk about is something called factoring completely. This basically just means factor as much as possible. Just means to factor until you can't factor anymore. That's all it means when you say factor completely. So let's say I have an example such as this: 20x squared minus 5, for example. Okay, I want to factor this completely. So what's the first thing I always want to see if I can factor first? What's the first thing? Anybody out there? What's the first thing we want to factor out if it's possible to factor out? What's the first kind of factoring technique that we discussed? The very first one. Nobody has an idea? Well, we have to factor out the GCF, guys. GCF. What's the GCF between 20 and 5? Do you see the GCF? The greatest common factor. It's 5, right? So when we take out the 5, that's my GCF. And when I take it out, what do I get? I get 4x squared minus 1, right? So normally we say, hey, factor out the GCF, I'm done. But am I really done? Isn't there more factoring to be done? What do you notice about the next expression here? What is this expression an example of? Out of all the factorizations that we talk about. So you can talk about quadratics. Yeah, that's right, Kalani. There's a difference. This is a difference of perfect squares. 4 is a perfect square. 1 is a perfect square. X squared is a perfect square. So then how do we factor that? What does 4x squared minus 1 factor into? Does everyone see that or not yet? So let me write this over here. 4x squared minus 1, right? Remember, we always want to rewrite this so that it's something squared minus another thing squared. So 4x squared can be rewritten as 2x parentheses squared. And then 1 squared is 1 squared. And then that's right, Samir. This becomes 2x plus 1, 2x minus 1. And therefore, I have completely factored because I cannot do anything further. I can't break down 2x plus 1 or 2x minus 1. It's called irreducible form. So it's as much as I can reduce this or factor. So that's my complete factorization. 20x squared minus 5 is completely factored into 5 times 2x plus 1 times 2x minus 1. Okay? So that's what we're going to be doing with this, guys. Okay, good. How about this? 16a minus 2a to the fourth. What can I factor out here? What's the first thing, like I said, that we can factor? We can factor out the what did we do in the first one? We factored out the GCF. So what is the GCF among 16a and 2a to the fourth? A 2, but is that the GCF? Remember, look at the other variables, a and a to the fourth. What do we do when we want to find the GCF of variables? We always look for the smallest power. So what's the smallest power among a and a to the fourth? A really has a 1, right? So the GCF is not just 2, the GCF is 2a. That's my GCF. So when I factor out the 2a, what's left? When I factor out 2a from the expression, what do I have in the parentheses? We have a, 8, that's right. We got 8 minus a cubed. Awesome. Very good. Very good. So now that we have this expression, are we done with factoring? What is this that I have here? What kind of, can I factor this further? What does this factor into? Very good, Samir. This is a difference of perfect cubes. So you got to remember, what is the difference of perfect cubes? It's 8 cubed minus b cubed equals a minus b, a squared plus ab plus b squared. That's the form. So then I can rewrite this as, if you want, 2 cubed minus a cubed. Now look what it has. It has a direct correspondence to this form here. So now all I have to do is plug it into the formula or to the factorization. And I'm left with 2a parentheses 2 minus a parentheses 2 squared plus 2a plus a squared. And I cannot factor this any further. And oh yeah, and then here I can just express what 2 squared is, which is 2a, 2 minus a, 4 plus 2a plus a squared. And that's it. That's it. And so I have factored the expression 16a minus a to the fourth as much as possible. I did it. Any questions about factoring completely of these two examples here? No questions? Okay, that's fine. Next one. What if I got 8x to the fourth minus 40x cubed plus 50x squared? What's the first thing that I can factor out of this? Out of these, this polynomial? What is the GCF among 8, 40, and 50? Anybody out there? No, no GCF. Well, what's the GCF among x to the fourth, x cubed, and x squared? What do I know for a fact that is the GCF from the variables? And x squared, right? Okay, good. But I need to also find the greatest common factor among 8, 40, and 50. So Jerry, the only problem with 8 being there is that 8 doesn't divide 50. So we have to find a number that divides all the numbers, 8, 40, and 50 as well. 8 only divides 8 and 40, not 50. So we have to choose another number. That's right, David, it's 2. 2 goes into 8, goes into 40, goes into 50, and that's the biggest number that does so, because anything above it, like 4, for example, does not go into 50. So 2x squared is my GCF. Okay, good. This is my GCF. So that means that what's left? I'm left with a 4x squared minus 20x plus 25. Now, what do I have here? 4x squared minus 20x plus 25. First of all, this is a trinomial, correct? A quadratic, it's a trinomial. And now the question I'm going to ask is, can I factor this? And if so, how do I factor this? There's 2 ways. So remember, when we have a quadratic such as this, we take the last number and the first number and we multiply it. So 4 times 25 is 100. We can do that, right? Or we can try to see what first. We can try to ask ourselves, is this a perfect square trinomial? Now, how do you determine whether something is a perfect square trinomial? Did anybody see my my previous lecture? So first we have to talk about the first and the last term, right? Are these perfect squares? And they are, aren't they? Isn't this really 2 parentheses squared, 2x squared? And isn't 25 really just 5 squared, right? Now, once we figured that these last and first terms are perfect squares, then we have to ask ourselves, what about the middle term? The middle term has to be what? Double the product of 2x and 5. What's the product between 2x and 5? Isn't it 10x? And if the product of 2x and 5 is 10x, and if you double it, don't you get 20x? So this is really what? This is really double the product of 2x and 5. What does this mean? This is an example of a perfect square. Trinomial. And what form is this? This is a squared minus 2ab plus b squared. That's a minus b parentheses squared. That's the factorization. So then this becomes what? Look how quick now this becomes. 2x squared. And what's going to be my a value here? My a value here is 2x. This is a, this is b, this is b. So the factorization becomes what? Definitely be a 2 out there, right? As exponent. This will be 2x minus 5. And I am done. Don't confuse this with squaring, okay? So this 2 does not mean I'm squaring each of these. That does not mean that. That 2 is not distributive as we know it. This is distributive, not this. This is an exponent. So 2x minus 5, because this is a perfect square trinomial, and this perfect square trinomial factors into 2x minus 5, parentheses squared. Okay? Any questions about that? If not, we'll move to the next one. 6x to the 5th minus 74, plus 74x to the 4th plus 24x cubed. So can anyone tell me what the GCF of this new polynomial is? What's GCF, guys? I guess you guys can't wait for spring break, huh? Well, it's coming, guys, but let's thank you.
X4. Oh, sorry. X3 is common, and
Yeah, x3 is the common factor, and Samir said 6.
So there won't be any division by 6. So 2 common.
2, right?
Yeah.
Right.
2.
The problem with 6 does not divide 74. That's the only problem. So we need a smaller number that divides 6 as well, and 74 and 24, and the smallest number is 2. So yes, this is GCF, right? Okay. So once we have the GCF though, then what's left? Yeah, I know. This 74 makes things a little more complicated. 72 will make it nicer. But 74 is like it's not as clean as 72. So when I factor out 2x cubed out of the polynomial, what do I get? 2x to the third, 2x to the third when I factor out a 6x to the 5th leaves 3x squared. When I take out the 2 from 74, what do I get? I get 37x, right? 37x. And then when I factor out the 2x cubed out of 24x cubed, I'm left with a plus what? Plus 12. And then I have a trinomial again, right? It's very similar to what I got here. I got a trinomial. But now let me ask, is this a perfect square trinomial? Or can I just disregard the whole perfect square trinomial? Well, remember, how do we determine whether a trinomial is a perfect square? We look at the first and the last terms. Are they perfect squares? Where obviously 12 is not a perfect square, and 3 is not a perfect square. So these are not perfect squares, so therefore it is not a perfect square trinomial. But regardless, can we factor this? And how do we factor this again? We use the AC method, right? We take 3 and multiply it by 12, and we get what? 36. And then we ask ourselves, what multiplies to 36? That when you add them up, give me 37. So what two numbers multiply to 36? When you add, give me 37. And I think that should be easy enough. That's right, David. Thank you. This should be 3x squared. This is going to be plus 36x plus 1x. Right? 36 plus x is exactly 37x. And then what do? We take the first group and the second group. So the first group, what can I factor out of the first group? 3x squared plus 36x. I can factor out a 3x. That's right. If I factor out a 3x, I'm left with x plus 12. And what can I factor out of the second group? X plus 12. I can factor out a, well, what's the only thing I can take out? If there's nothing that I can take out, I just take out the 1. And then what do I notice? X plus 12, x plus 12, they're the same. So then when I factor this out, I'm left with x plus 12, 3x plus 1. And that is my factorization. Do you guys see that? So I factored using the AC method. AC method for quadratics. Okay. So look what we're doing, guys. We're applying factorization techniques together. GCF with difference of perfect squares. GCF with difference of perfect cubes. GCF with perfect square trinomials. GCF with AC method. So that's what we're going to be doing. Factoring as much as we can. And we'll be using different techniques for that. How about 16x to the fourth minus 81? What do I do here? Anybody recognize 16 and 81? Those two numbers are called what? What kind of numbers are 16 and 81? (16) is also known as a perfect square. That's right. Yeah. And 81 is also a perfect square. So I can write those as perfect squares. And is x to the fourth a perfect square? Is it possible to rewrite x to the fourth as something squared? Yes. So this is a difference of what? This is a difference of perfect squares. So this is difference of perfect squares. So let me write it as such. I can write this as what? 4x squared minus 9 squared. So 4x squared parentheses squared minus 9 squared. This becomes what? 4x squared plus 9 parentheses 4x squared minus 9 parentheses. So now I am factoring using difference of perfect squares. And now the question is, can I do further? Is it possible to apply factorization technique once more? Well, 4x squared plus 9, that's a sum of perfect squares, and there is no factorization for that. But if you look at the rightmost term here, a binomial, 4x squared minus 9, what is this also? This is also a difference of perfect squares. So for this example, I did difference of perfect squares. Then the result of that also has a difference of perfect squares within it. So let me factor 4x squared minus 9. What does 4x squared minus 9 factor into? 4 is a perfect square, 9 is a perfect square, x squared is perfect square. So I'm left with what? 2x plus 3, 2x minus 3, right? And then I can't factor any further. And that is my factored form. 4x squared plus 9 times 2x plus 3 times 2x minus 3. That's right, David. There's a lot of inception in math. It's just something goes in further into another thing, into another thing. We can do more of these where you have several difference of perfect squares embedded within it, and that gets kind of crazy. But the whole point is, guys, that this is possible, right? It's possible that you have a difference of perfect squares. When you factor, you get another difference of perfect squares. Or it could be possible that you have a difference of perfect cubes and then it becomes difference of perfect squares. Things of this nature can happen. Okay, so I'm gonna do one more and then we can move on. So what if I get something like this? 2x cubed plus x squared minus 32, x minus 16. So here, guys, what do we have? We have 4 terms. So the immediate thing you should think about is, you should immediately think about factor by grouping. So when I factor by grouping, the first group, I get a x squared out of here, and I'm left with a, so x squared, I'm left with a 2x plus 1. And what can I factor out the second group? I can factor out a what? I can factor out a 16, a negative 16, right? Because they both have negatives. So when I factor that out, I'm also left with the 2x plus 1. And then what do I notice? 2x plus 1, 2x plus 1 appear in both terms. So because they're the common factor of 2x plus 1, I can take out the 2x plus 1, and I'm left with x squared minus 16. But then does anybody notice something about one of the factors? 2x plus 1 and x squared minus 16? What do you notice about this? X squared minus 16 is also a what? Can I factor this further? X squared minus 16, yes, it's a difference. It's a difference of perfect squares. So I can write this as 2x plus 1, x plus 4, x minus 4. And I'm done. I can't factor this any further. But you see here, I had factor by grouping, and then I'm left with a common factor. I factor that out, and I'm left with a difference of perfect squares, which I can factor further. So you'll always have to be perceptive as to what you can actually, what kind of terms, what kind of expressions we have. Okay, so all of these is building up our skill set, particularly with factoring. And like I've said, factoring is going to carry you all the way through. Even when you do higher level mathematics, if you guys do any higher level math courses, factoring is going to be embedded in all of your classes. So it's a worthwhile technique to master. Okay, so we talked about factoring completely, and factoring completely just really means factor until you can't factor any longer. Now, how do we use factoring, particularly in mathematics? A lot of times we use it to solve equations. So we're going to solve equations now by factoring. That's what we're going to do. So now the only difference now is that not only are we going to factor, we're going to do something, we're going to complete it. We're going to complete our objective, which is to solve for the x value. So I'll give you an example. I have the equation x squared minus 3x equals 0. So now I have an equal sign, and my objective is to solve for x, right? Solve for x. And when I mean solve for x, I mean get a value for x that makes, so this, I just want to say, this means to find the value, or plural, values of x that make equation true. That's what it means to solve. When you solve an equation, you're solving for the x value that when you plug it into the original equation, it gives you a true statement. Now, what do you notice? Forget about the equal 0 part for a moment, and just focus on x squared minus 3x. And the question is, can we factor this? So can we factor this? What can we factor out of x squared and 3x? I can factor a what? I can factor out an x. That's right. So GCF here is x. And I'm left with an x minus 3 equals 0. Now, what happens here? There's something called the principle in your book. It's called the principle of zero products. So what's the principle of zero products? The principle is this. If you have two things and when you multiply them, it gives you 0, then A equals 0 or B equals 0. That's the principle. That's all. So what do I have here? I have to apply that principle here, don't I? X times x minus 3, something times another thing, when it equals 0, normally we write this t-chart thing, right? We're normally going to say the following. Either x equals 0, or we say that x minus 3 equals 0. So x already equals 0. That's one of my answers. That's one solution. And then what's my other solution? X equals 3 when I solve for this equation. So those are my two solutions. When you solve, you get solutions. So what are my solutions here? My solutions is that x is equal to, and I put the curly braces, 0 or 3. Make sense, guys? Now we're factoring, and when we factor, we have to do a few more steps. We have to solve for x. So factoring helps. Factoring is a crucial part. Most of the time, we won't be able to factor, but when we are able to factor, please do so. Okay, I'll give you another one. 2x squared minus 5x equals 12. Again, I want to solve for x. Can I solve for x? Now you may think, oh, I need to factor the left hands first, right? I can factor out the x. But the problem is there's not going to be a zero. And this principle is what we need. We need always to use the principle of zero products. So before anything, note, to solve any equation, set equation equal to 0. That's all you have to do. So first thing, order of business is set it equal to 0. So subtract 12 on both sides. When I subtract 12 on both sides, what happens to the right-hand side? It becomes 0. And the left-hand side becomes 2x squared minus 5x minus 12 equals 0. And now what do we have on the right-hand side? I mean, on the left-hand side, we have a trinomial. Now, how do we factor, if possible, this trinomial? What do we have to do? Eight x plus 3x. That's right. That's right. That's right, Meg. So we multiply 2 and negative 12, right? And I get negative 24. And then I find two numbers that add to negative 5, but multiply to negative 24. And it's exactly right, negative 8 and 3. So I can write this now as 2x squared minus 8x plus 3x minus 12 equals 0. So I'm using the AC method. And then I have to do what? First group, second group. The first group, I can take out a 2x. I'm left with an x minus 4. The second group, I can take out a 3. And I got x minus 4. That equals 0. Then I can factor out the x minus 4 with the x minus 4. 2x plus 3 equals 0. So I factored out the trinomial, and now I have two products, a product of two expressions that equal 0. So then by the principle, right, I'm going to write it over here, x minus 4, 2x plus 3. There's a multiplication in between these two parentheses. So by the principle that I just spoke of, either x minus 4 equals 0 or 2x plus 3 equals 0. Then on the left side, what's the result? I get that x equals 4. And then on the right side, to solve for x, I subtract 3 on both sides. I'm left with 2x minus 3, divide by 2, divide by 2. And I'm left with x equals negative 3 halves. So then what's my solution? My solution is curly braces, negative 3 over 2, comma 4. Make sense? Does everyone see how we're using factoring now to solve equations? Okay. Any questions about this one? Okay. So that's clear, guys. Let's look at the next one. Now, the next one looks a little crazy because we have on the right side an expression in parentheses and there's a term right outside of it. And I want to solve it, right? In this case, I want to solve not for x, I want to solve for t. So solve for t. Okay. I want to get t by itself. But in order to do that, first I need to distribute this t because I don't want the parentheses. I don't want any parentheses. So when I distribute the t, what do I get? I get t squared plus 8t. Now, remember what's the note that I wrote? To solve any equation, set equation equal to 0. The problem is it's not equal to 0 yet. I need to solve it. I need to set equal to 0 first. So what I could do is I can subtract the t on both sides here, subtract the 18 on both sides here, and then look what I get. On the left side, the t's cancel, the 18's cancel, and I'm left with 0 equals t squared plus 7t minus 18. Now look what I have. I have a trinomial set equal to 0. Now, can anyone tell me how to factor t squared plus 7t minus 18? This is a trinomial that I can factor. So what does this factor into? This should be rapid speed, rapid. It should be t squared plus 7t is, boom. Yes, yes. Well, Samir, it's the other way around. It's not negative 9t plus 2t. And remember when we have it in this form where there's a 1 in front of the t squared, we should already immediately know the factorization. The first terms are t's because they give us the first term, t squared. So all we have to really figure out for this is what numbers multiply to negative 18, but when you add them, give me 7. So you got the right numbers, you just have to flip the sign for each. Still sleepy, huh? Yeah. Plus 9. So it's going to be t plus 9, and this will be t minus 2. So now look what we have. Two terms multiplied with one another gives me 0. So then I know that I can do this little t chart and say, well, then it has to be that t plus 9 equals 0 or t minus 2 equals 0, one or the other. So I know that t equals negative 9 and t equals positive 2. So I solve for t. And then what are my solutions then? T is equal to negative 9 comma 2. And that's my solution. And that's how you solve it. We distributed the t, we set it equal to 0, we factored it, then we use the principle of zero products. Each part of the product, factor of the product, has to be set equal to 0, solve those small equations for t, and I get -9 and 2. Okay? So that's how we're using factoring to solve. That's how we are. And now I want to talk about something that we've discussed in the past, which are zeros of a function. Zeros of a function. So the zeros of a function, recall, are the x values that have, or you can say these are the input values. These are the input values that have a y value or output value of 0 when they are input, when the x values serve as input to the function. In other words, the zeros of a function is the same, similar, it's nearly identical to the solution to an equation. It's just that a function is a little bit different from an equation, slightly different. Because a function, you're naming a certain operation, whereas an equation, you're just setting things equal to one another. It's a slight difference. It's not necessarily an entire difference, but it's a slight difference. So what do I mean by that? So for example, if I have a function, not an equation, but I have a function, x squared minus 2x minus 8, right? This is a function. This is the way you describe a function. And I say, hey, find the zeros of f. Find the zeros of f of x. I want to find the zeros of my function f of x. Well, remember, the zeros are the x values whose y value is 0 when the x value is placed inside the function. So then this means that I'm going to set my function equal to 0. That's what I'm doing. Find the zeros is find the x values whose function, when I plug in the x value, gives me 0. But what is this function? It's what? It's x squared minus 2x minus 8 equals 0. That's my function. And now look what we have here. It's exactly what we've been doing in the previous problems. We have an equation. Now we have the equation set equal to 0. And then we factor. And we know that this must be x, this must be x. So what multiplies to -8? But when you add it, give me -2. That's -4 plus 2. And then I split this up. I get that x minus 4 equals 0. Or I get that x plus 2 equals 0. So x equals -2. X equals +4. So what did I figure out? I figured out the solution to my equation. So these are solutions to this equation, but they also serve as the zeros of function. So that's why they're kind of basically the same thing. The solutions to this equation, it happens to be the zeros of my original function. So again, I'm looking for the zeros, right? So what are the zeros of f of x? Well, x is going to be equal to -2 and 4. So those are my zeros. Okay, so the zeros. So one thing I want to note that the zeros of a function is synonymous synonymous with the solutions of an equation. Again, they're nearly the same thing. They're essentially the same thing. But one is dealing with an equation, the other one is dealing with the function. Functions can become equations and vice versa. So when you hear the word zeros, you should think of solutions. When you think of solutions, you think of zeros. And so then let me just give you the whole thing. So the words that are synonymous are very much these words. So zeros, right? And this word means equivalent, okay? These three horizontal lines means equivalent. It's equivalent to saying solutions. And it's equivalent to saying the roots. And that's equivalent to saying the x-intercepts. So all of these words here, they represent slightly different aspects of about the same thing. The zeros means when you plug in the x value, you get 0 as a solution, as a result. The solutions means that when you plug in that x value to the equation, it makes it true. Same thing goes for the roots. And of course, if you graph those zeros, or if you graph the solutions, or if you graph the roots, you're speaking about the x-intercepts. Because remember, with the x-intercept is when y equals 0, which comes right back to what zeros are. It makes the y value 0. So all these words are equivalent, similar to one another. Okay? So any questions about zeros? Any questions about factoring to solve equations? Is this crystal clear? Looks like many of you out there still sleepy, right? Sleepy time. All right. Okay, let me give you one for you guys to do at home. So I want you to solve the equation. I'm gonna give you the equation. It's 3v plus 2 parentheses v minus 4 equals v squared plus v plus 5. So I'm gonna give you I think this is one for one equation. I'm gonna give you about 4 or 5 minutes here and try to solve this on your own. So again, I want to get the equation, I want to get it where one side equals 0. And then I want to see on the other side whether I can factor it or not. So why don't you take your 4 to 5 minutes to do so. Very good. Very good, Meg. -1 and 13 over 2. Very good. So you distributed everything, right? You distributed these terms inside, and you got what? 3v squared minus 4, pardon me, minus 12v plus 2v minus 8. This equals v squared plus v plus 5. Then you can combine these and you get 3v squared minus 10v minus 8 equals v squared plus v plus 5. But of course, we want to set it equal to 0, right? So we subtract v squared, we subtract v squared, these cancel. We subtract v, we subtract v, these cancel. Subtract 5, subtract 5. And then we get on the left side 0, which is what we want. And we got 2v squared minus 11v minus 13. And then what do? We multiply 2 and negative 13 together. So when we do 2 and negative 13 together, we get negative 26. And then what do? We have to try to find two numbers that add. Well, actually, it's exactly those two numbers, right? That multiply negative 13 and 2 multiply to negative 26. But when you add them, give me negative 11. So I get 2v squared minus 13v plus 2v minus 13 equals 0. And then I can factor the first two terms and the last two terms. I can factor out a v, and I'm left with v, and this is 2v minus 13 plus 1 times 2v minus 13 equals 0. And I recognize 2v minus 2v can be factored out, and I get 2v minus 13 v plus 1 equals 0. And then I can make each of these factors, I can make them set equal to 0 and solve. And then, Meng, you're exactly right. V is equal to negative 1. And when you solve this, V is 13 over 2. So I did it. I solved both. So I have the zeros, or the solutions. The solution is V is equal to curly braces negative 1 and 13 over 2 curly braces. Again, curly braces indicates a set. This is a set of solutions. This is my solution set. Very good. Very good. Okay. Now I'm going to do two more things, and we will be done for today. So I just want to do one more thing with the finding the zeros. So find the zeros. Find the zeros of the function to this function. G of x equals 6x squared plus 13x minus 5. So I want to find the zeros of this function. Remember, the zeros is very similar to the solutions, right? So what I mean by the solutions is I want to set my function, my zeros, I want to set my function equal to 0. That's what it means. I want to find the x values that make my function equal to 0. But my function here is 6x squared plus 13x minus 5. That has to equal 0. And then I do the same thing again, right? The 6 and the negative 5, when you multiply them, give me negative 30. What two numbers multiply to negative 30? But give me, when you add them, give me 13. Positive 13. So can anyone give me those numbers? So what multiplies to negative 30, but when you add them, give me negative 13? That is right. It is positive 15x minus 2x. And then you factor the first group, right? The first group you can factor out a 3x, and this is 2x plus 5. The second group, I can only factor out a negative 1, and I get 2x plus 5. That equals 0. Then I get 2x plus 5, 2x plus 5. I can factor that out, and I'm left with 2x plus 5, parentheses, 3x minus 1. That equals 0. And then I get 2x plus 5 equals 0, and I get 3x minus 1. That equals 0. So then I get x equals 1/3, and I get that x equals -5/2. Okay, and so what are my zeros? I want the zeros. The zeros are x is equal to -5/2, 1/3. Okay, so that's how you find the zeros of a function. You just set it equal to 0 and you solve. And you solve by using factoring. So factoring becomes very useful when we talk about solving for the zeros or solving for the solution. Okay, any questions about this? So if there are no questions, of course, we always want to talk about the applications, right? How do you apply this in real life, quote unquote? So let me give you a scenario. Now, suppose I have a rectangular piece of cardboard is 10 inches longer than it is wide. Then we have squares of 2 inches each side, 2 inches on each side are cut out from each corner. And the sides are folded up to make an open box, with a volume of 112 inches cubed. It says find the length. Find the length and width of the cardboard. So this requires a little bit more geometric understanding. So first of all, we start with the piece of cardboard, right? And it's rectangular, correct? So drawing helps. So we have a piece of cardboard, and what do we know? It says that the length is 10 inches longer than its width. Now this is when we have to become problem solvers. How do you become a problem solver? Well, the first thing is we identify what we don't know. I do not know what the width is. Because I don't know what the width is, I say, hey, you know what? Call this x. So let x equal the width of rectangle. And then I know that the length is what? 10 inches longer. So whatever the width is, the length will be 10 plus x. Or I should say x plus 10. It doesn't really matter, but just to make sure. X plus 10 is 10 more than the width. So x plus 10 is the length of rectangle. Now, what do we do with that rectangle? What does it say? Squares of 2 inches on each side. So we have little squares that are cut out. And again, each of these squares is 2. Each of these squares, the sides are 2, 2, 2. This is 2. This is 2. This is 2. This is 2, right? And there's squares. And then what happens after we cut out those squares? So we cut them out. They're not there anymore. So after they're cut out, what do? Their sides are flipped open. The slides are folded up. And what does that mean? We're making a cardboard box that's opened up. And when we do that, we get something that looks like this. We get something that looks like this. Now the question is, what is this new piece here? What is this new piece? What is this new length? Well, this was x plus 10 originally, right? But then what do? We subtracted 2. We subtracted 2 on both of these sides. So this side is going to be what? X plus 10 minus 4 because I'm subtracting 2 on both sides. So this becomes x plus 6. This is my new length of my box, right? This is the length of the box, length of open box. And then what's going to be my width of the open box? This is originally x, right? But then we subtract 2 from it. That's a total of 4. So this becomes x minus 4. This is the width of box. And finally, we need the height. What's going to be the height? The height is here. But what is the height? The height comes from this flap here, the square, the length of the square. So my height here is 2. And then what's the last thing we know? The volume is 112. How do you find the volume of a rectangular box? The volume of a box, or a rectangular prism as they call it, is equal to the length times the width times the height. What's the length? X plus 6. What's the height? What's the width? X minus 4. And what's the height? Times 2. And what does the volume equal? It has to equal what? 112. So look what I have. I have this equation, x plus 6 multiplied by x minus 4 times 2 equals 112. So I can factor out this stuff here. I can expand everything, right? This becomes x squared minus 4x plus 6x minus 24 multiplied by 2 divided by 112. What I can do is I can divide the 2 on both sides. And then I get x squared plus 2x minus 24. And if you divide 112, you get 56. But of course, I want to solve this equation. Subtract 56 on both sides. So I get x squared plus 2x minus 80 equals 0. And now I want to solve this. So how do I solve this? I find two numbers that, when I multiply to negative 80, give me positive 2. And what are those two x values? What are those two values? Plus 10 and minus 8, right? And then I solve. X equals 8, x equals negative 10. I got two solutions, right? The problem is, however, when we're talking about this context of the problem, we're talking about distance and length. So it makes no sense to have a negative 10 distance. So what we do here is we reject this. And we use x equals 8. And x equals 8 is my width. Because that's exactly what I said x was, right? X is the width of the rectangle. So I found x equals being the width of rectangle. And then what do I know about the length? The length of the rectangle is always going to be what? 10 more, right? So just add 10 to 8 and you get 18. So what are the dimensions of my rectangle? Dimensions of rectangle. It's the length is 18 inches and the width is 8 inches. And so this is how we use solving and factoring to solve real world examples, such as this one. Of course, this is an elementary one, but this is just the way we start seeing the applications of solving equations.